Welcome to the Digital Analytics Power Hour. Tim, Michael, Mo, and the occasional guest discussing digital analytics issues of the day. Find them on Facebook at facebook.com/analytics hour and their website analyticshour.io. And now, the Digital Analytics Power Hour.
Hi everyone, welcome to the Digital Analytics Power Hour. This is episode 124. You know, have you filled out one of those CAPTCHAs that ask you to pick all the images with a stop sign, or has a storefront in it, or have you laughed along at the Silicon Valley show when Jin Yang created his app that could tell you whether you were looking at what was a hot dog or not a hot dog? And what does this actually have to do with me, the analyst or data scientist? Well, it's pretty cool, and you have to have a lot of data to do it, and it's machine vision, and so it totally qualifies. And so we're going to talk about it. Mo, do you think this qualifies as a topic for the show?
Oh, I'm so freaking excited. I'm not going to lie.
Excellent. What about you, Tim? As if anybody cared about your opinion.
Well, I'd like you to frame the question in the form of a picture, and then I will draw a picture in response.
Okay. Yeah. Yep. I just uploaded it to the Measure Slack, so you can respond to it there. All right. But we needed someone to help explore our vision, boom, pun intended, for this topic in more detail with us. Ali Vanderveld is Director of Data Science at ShopRunner. Prior to ShopRunner, she held data science roles at Civis Analytics and Groupon. She's an astrophysicist turned data scientist, and today she is our guest. Welcome to the show, Ali.
Thanks. It's great to be here.
It's so great to have you. Okay, to get us kicked off, we need to level set or start out with something where everybody can get on the same page of what we're talking about. So maybe, if you wouldn't mind, kick us off with just a 101 on machine vision or computer vision, whatever it's called, the future, computers knowing what they're looking at.
Yeah, definitely. Okay, well, first of all, you mentioned that I have a background in astrophysics, and fun fact, there are images there too. So it all connects. But yeah, usually when we look at pictures, like say a picture of a galaxy or a picture of a hot dog, we don't usually think of it as being data, but all these pictures actually are data. So if you take an image and you take all the pixel values and every color band, so let's say RGB, you can put all of those numbers into a vector, and that vector could be the features that go into a predictive model. And that's basically all we're doing with computer vision or machine vision, taking all the data that you have in the raw pixel values of an image and feeding them into a machine learning model to try to learn things about that image. So the standard classic problem that people talk about in this space is based on a database of black and white handwritten digits called Analyst. And what people do is they take these black and white images, and then from the data in that image, try to predict what the actual number is. And we really love at my company a framework for doing this called deep learning. So deep neural networks have been able to achieve human level accuracy in this task of predicting these digits from these handwritten images. So fashion is an inherently visual thing. And so it's been a big push in the tech scene lately to figure out what we can do with computer vision in the fashion space. And so my team at ShopRunner is working on a bunch of cool stuff in that area.
Okay, and so what's with the computer vision and machine vision? Like, what is it just like got two names, or?
I was thinking the same thing. Is one like old and uncool?
Is it like SQL and SQL? I don't know.
Yes, it is. Yeah, it's the same thing.
Oh, okay. Just someone decided to have a slightly different variation in naming.
Yeah.
And outside of fashion, what are some of the other use cases, I guess, that people in the industry at the moment are really looking towards?
So yeah, there's a ton of stuff. One example of something that we also participate in my company is computer vision for wildlife conservation, if you would believe it. So the Lincoln Park Zoo in Chicago, actually, they work closely with Uptake and my company, ShopRunner, to work on this open source package called Autofocus, where they have camera traps set up throughout the city that take video of everything that's passing by. And we use computer vision to figure out when in that video is there a human or an animal present. And then when there is an animal, what kind of animal is it? And so the whole point here is to track animal populations throughout the urban environment to try to help preserve their populations. So that's one specific thing you can use it for. It's also being used in medicine, where people are trying to train the same kinds of deep learning models to look at various kinds of scans you could take of patients and figure out if they have various cancers or things like that. And then people are also using computer vision for things like self-driving cars, actually. So self-driving car, you'd have the scene in front of you. So that'd be an image. And then you can have some sort of LiDAR or something telling you how far away things are from you. And you use those different signals together to figure out, should I brake? Should I turn right? What should I do? So those are some of the most exciting to me things that people are using computer vision for.
I wonder if we should back up and have you quickly kind of recap how ShopRunner uses it, because that's like, you guys are a kind of unique business model and have a very kind of direct and cool application.
Yeah. Let me just back up and just say what ShopRunner is. But so I'm sure you've all heard of something called Amazon Prime.
What?
Right? Stop me if you haven't heard about this.
Well, in fairness, it's new to Australia. So
Yeah, that's true for European listeners. There's not as much of that out there.
Yeah. So Amazon Prime it's like completely changed the game for e-commerce. So their site just makes it so incredibly easy and convenient to shop across, like millions and millions of products. So they've just made it so easy and seamless that it's just kind of raised the bar for what customers expect in an e-commerce setting. So it's become kind of difficult for traditional retailers to keep up. So what ShopRunner is doing is we're partnering with over 100 different retailers so far and providing them with a suite of tech tools, basically, that can plug natively into their website to basically Amazonify it a bit. So we give them tools like express checkout, out-of-stock notifications, fraud monitoring, and even like a widget to tell you what's trending right now in different cities. So we provide that to our retailers. And then on the other side, we have millions of customer members, and then they get a bunch of benefits from their membership, including 2-day free shipping and seamless checkout and exclusive deals. So we're bringing all these new customers to the retailers as well. They tend to be very high engagement customers.
do you funnel them to the retailers, like refer them, or like people could buy products on your site?
So people can buy products through our site, but the main way that our customers buy products is through the retailer's native site. So we'll send them marketing emails that they're aware of deals that are coming up and things like that. But it's mostly based on helping the retailer create an easier shopping experience on their own native site. And then we're also working on a mobile shopping app that's called District. So that brings everything together in one place. So you could shop across this 100 plus retailers with one universal cart and all this fancy shopping tech that we provide.
And then the image stuff comes into play.
Yeah. Okay. So, so a lot of it has to deal with helping our customers find what they want to buy. So at a very, very basic level, if you want to take all the products from 100 retailers and put them into one catalog in one mobile shopping app, you have to, first of all, merge all the taxonomies together. So a taxonomy is basically how you categorize the products. So if you go to like two of our bigger retailers are Bloomingdale's and Neiman Marcus, and if you go to their websites, if you have the same shirt, they'll both kind of call it a different thing. So as you're like browsing through the website, the flow will be different as you drill down to what you want. And so if we want to merge that all together into one experience, we have to have one master taxonomy that we use for everything. And then also to help people find what they're looking for, we can create filters. So like, what color is this? Does it have a pattern? What length is the skirt? How long are these sleeves? Things like that. So we can use computer vision to, if we get in a product catalog from two different retailers that have their own ways of categorizing things, we can just take the raw product data and categorize it however we want to on our mobile app so that people can much more easily find what they're looking for. And even beyond that, there's a lot of cool stuff we can do with computer vision. One of the things I'm most excited about is visual similarity. So if you have one seed product someone's interested in, but maybe it's too expensive or it's not the right color or something like that, but they want something with a similar shape, you can actually use a computer vision model to show them other things that they might be more interested in based on the images themselves.
So are you using any of the metadata that the retailers provide, or are you essentially, I mentioned to you before we started, I worked in retail, and everything at my company was manually tagged in terms of like category and color and size and all that stuff. And I mean, anytime you have a human doing that stuff, there's going to be mistakes or differences in opinion, even just like color. So how, like, are you using that metadata, or is it all just so rubbish you kind of need to throw the bathwater out?
Well, and let me ask if there's metadata for the product that is in their feed, but then presumably I think there's also metadata in the images that come with it. So if you could maybe cover both of those as well.
Yeah. So one like aside, you mentioned human labeling of all this stuff. That's actually what we're trying to avoid here. We're trying to build an automated system to get labels for all of these items. And that's because we just have millions of products. And taking millions of products and manually labeling them is super labor intensive. So we've been training this model to do it so that there's a confidence threshold that we give. And we say if the model is above some level of confidence, then we can take that answer. And if it's not, then a human labels it. So by doing that, we're able to dramatically reduce the number of products that we have to send to a human. So in terms of what data we use, you're right, we do get a lot more data from the retailer than just the image. And actually we could get multiple images. So we can get one or more images, and then we also get like the name of the product and the text description and like whatever category they call it on their native site. Yeah, there are lots of pieces of data that we get. So the way we are combining that all together is by using not just computer vision, but also natural language processing techniques. So we take the image and we run it through a computer vision model, but then we take all the text and we run that through an NLP model. And so each of those models is going to have their own predictions for what is in that item. So like if you're looking at a model for color, for example, the image is probably going to give you a pretty good idea of what color it is, but that's also going to be represented in the text. They're probably going to say like, this is red, or they might have some funky word for red, but it'll probably be in there too. So by combining the two models together, we can get predictions that are way more confident. And then also it helps us in cases where the image just might not be enough. So like one classic example I bring up is women's versus men's athletic shoes can tend to look really, really similar. So an image model might not know, but the word women or men will tend to be in the text. And so the text model will help do that discrimination. Or like color jeans versus pants, also like the image model doesn't know. Or what material is this? Or does this dress have pockets? You know, there are just some things where having the text data is super, super handy. So we combine them both together.
And do they also provide do they say, here's our taxonomy in some sort of XML or and their category may be completely unique because they're geared towards Brooklyn hipsters and think about things in a totally different.
Exactly.
I mean, does that even kind of structured data get factored in as well?
Oh yeah, totally. We have the native category. So that'll be like a series of like the taxonomy tree, like as you go down the tree. So this is like women's clothing, pants, crops, you know, like you'll go down the list. And so we break that out, and then all those words are fed into our natural language processing model. So yeah, they do give us those categories, and they're usually useful, but sometimes it's something like summer sale or something like that, where it's actually not useful. But for the most part, that data is also super useful. So yeah, we use it as well.
So this is like a fairly new-ish space in terms of e-commerce. Like, what kind of training data exist out there for you to use? Or is that, I mean, part of the problem that you have to, like, what are people doing to solve that problem?
Yeah, so they're actually, now a lot of companies, like tech companies that are focusing purely on annotating data for tech companies. So it's become like a really big business of not just image annotation, but all sorts of data annotation. So we do use a couple third-party companies for this kind of stuff. So for crowdsourcing image labels, we use one company called TaskUs, where you give them an actual like detailed manual, and you have people working on the images that are trained in the fashion space. And then we also use Figure 8, which is less specific, but higher volume. So they're both like been very good for getting us annotated data. But yeah, you're right. That's honestly the hardest part of this problem is getting labeled data for these problems. And then there are some of the things that we're doing with computer vision where there isn't even a right answer. So I mentioned before visually similar items. So like someone has an item they're interested in, but they want to see what's visually similar to it. We can give them a recommendation of a list of 10 items, but is that right or is it not? Like, how do you test something like that? So
yeah, what did your model say about blue dress versus gold dress? I'm just curious.
Yeah, but to be fair, like I had this the other day. I was shopping on an online retailer who shall remain nameless, and I hit like show me visually similar items, and I went from like a floor length black dress to a bikini, and I'm like, oh, I can see how it happened because like the neckline was similar.
Oh yeah,
but I'm definitely not shopping for a bikini right now. So
yeah. So the way we're doing that is it's pretty cool. So we have this model that tells us where something falls in the taxonomy, so like what it is, and that's based a lot on the shape of the object. And then we have a different model that tells us the color and pattern of the item, but it kind of ignores the shape. So we actually take the results of both of those models and we merge them together and use that in our visually similar API. And so it tends to give us things that are the same shape and the same color and pattern. And so far, we've been testing it versus, like itself, like different iterations of it. But at the end of the day, with something like that, you just have to put it in front of customers and see if they click on it.
Well, this is one of as we were kind of prepping, and I found a technology review article about the amount of training and tagging. And then, Ali, you'd said, oh, look at this New York Times article. I was kind of surprised, and I don't know to what extent you can kind of explain. I feel like there's this idea that, oh yeah, you need a training set. So, give somebody 1,000 pictures, have them tag it, and now you're off to the races. But I mean, one of the examples was like, oh, tagging cancer cells. And I think that's one that I would have thought, oh, well, you tag 1,000 cancer cells and then you're done. So can you explain kind of some of the mechanics as to what the scale of kind of training and tagging is needed?
Well, okay. So the amount of training data you need depends on several different factors. But if you think of how many different pixels are in an image, and you think of how many different, like if you take the same shirt and you take a bunch of different pictures of it, they can all look pretty different. So if you're trying to build, say, a category model, I think a general rule of thumb is you need 100 to 1,000 different examples for each category. So now, like in our taxonomy, just in clothing, we have 400 different categories. So then if for each of those, we want to have at least 100 images, like you can see how it can get, like you need more and more and more. And then that's just for getting the category. If we then want the color and we want the pattern and we want what season it's good for and the neckline and things like that, like for every aspect that we build a model for, we need more training data for every category. So if you think of all the different taxonomy categories plus all the different color categories plus all the different pattern, and you multiply them all together to get the total number of possibilities, and then you multiply that by 100, it's a lot of stuff. It's a lot of annotated images you need.
So yeah, we were talking about this quite a lot with retail and sizing as well. Like sizing is such a horrific problem for shoppers. Like finding what you need and sizing, those are the two problems that are hardest to solve. And there's almost this like, do all retailers in the world need to combine their data so that there would actually be enough for everyone to have really good models, but then you're solving the problem for everyone. So there like goes the whole competition thing.
Right.
I don't know.
Yeah. That's really hard. For sizing, like you don't want to just see like what people, you could take like every person and look at all the clothing they bought across a bunch of different brands and see how the sizes match up. But you want to know, like, if they returned something, why did they return it? Did they return it because it didn't fit, right? And it's like getting that data for not just what they kept, but what didn't work and why is why some companies are much better positioned to get that data in-house than other companies. Like companies like Stitch Fix and Trunk Club that give their customers like a batch of new clothes very regularly, they get that feedback back where people are like, yeah, this didn't fit me and it was too big or it was too small. So companies like that definitely have a competitive advantage in terms of actually having the data they would need to build that kind of model. But you're right, sizing is super hard and we have not attempted it yet.
So I have so many questions. Like, okay. I feel like you're in the, and I'm kind of in the world of, it just seems like magic and it seems like let's just add a new category or let's just add this new thing. The rational me imagines that there has to be some sort of crazy kind of intake and prioritization process. And obviously without doing anything proprietary, do you have like a mountain of requests for, can we do this other thing that you guys have to prioritize? And what are kind of the considerations? Like you mentioned, like presumably there's a calculation saying, what's this going to cost us in human tagging? Like how do you go about saying what's a new capability that we want to add to our system?
Yeah, so that's a really good question. Well, we're trying to get the basics done first. And so figuring out the taxonomy was the first thing we wanted to do. And now we're working on all these, what we're calling them attribute tags. So all these different things that I think of the taxonomy as like if you're browsing on a website, that's how you find the category you want. But then attribute tags are good for building custom filters. So in terms of those, we definitely have a prioritized list and some are a lot easier than others. So we really just went for the low-hanging fruit first, and all the low-hanging fruit ended up being super useful. So that's why I've mentioned color and pattern and like skirt or pants length and then sleeve length. Those ended up being the easiest to build for the attributes. And what we've tried really, really hard to do is build a system that's as extensible as possible. So whenever we get, like, people ask for a new attribute that they want, like, working on like season, is this good for winter, spring, summer, or fall? When we get a new attribute request, we're trying to minimize the amount of work that we have by reusing the existing architecture. So this might be getting a little too into the weeds, but we're doing something called multitask learning. So basically, we have one big deep neural network that we put our data into, and it gives us what we call an embedding vector. So it's just taking an image and representing it as a smaller vector representation of what's in it. And then we take that vector and we can put it in any kind of model we want. So we put it in the color model, the season model. Because it's this really well formulated vector representation of an image, it is this multi-purpose thing that we can repurpose for different types of attributes. So because we've been trying to be really smart about how we build our architecture for our modeling, it's made it much easier to incorporate new things. The hardest part is getting the annotated data. So that's another consideration, is how much is it going to cost to get the annotated data for this attribute? So getting it for season is actually not that hard, relatively speaking. But let's say we had something like, one example of a thing you could do is sleeve type. Apparently there are like 30 different kinds of sleeves you can have. And this is something...
I'd believe it. I'd totally believe it.
Oh, and Mo could probably list like 17 of them without even blinking.
There's so many sleeves. Like, I don't know why. I've learned so much about fashion since starting this job, because I'm, as you guys can see, like, I'm just wearing like a hoodie right now, and that's all I wear. And it has one sleeve type. It's the hoodie sleeve type. But apparently there are a lot of others. And so that's like one. So there's like the ROI of the new attribute, right? So there's a lot of market research that our product team does to look at other websites and see what they do and what creates a seamless shopping experience. And then that gets weighed against how hard it is to get the training data. And the more categories there are to an attribute, the harder it is to get the data for. And then the fuzzier the categories are, the harder. So something like sleeve type, it's not a super hard and fast thing, but something like the color of an image, like that's a lot easier to define. But fun fact, color is actually a lot harder than you might think.
Why is that?
It's so subjective. Like there was one time where two of my coworkers were arguing over what color a dress was. And so they brought me over and they're like, what color is this dress? And I apparently said a third color. So one of them thought it was red. Another one thought it was brown. And I thought it was purple.
But it also depends, like even just the photography. And like, we used to have heaps of photos that were stripes and the stripes just don't show up on film for some reason. And you don't have the physical product in front of you. So it's not like you can just be like, oh, let me check that.
It's that whole like blue versus black dress thing all over again. Like it's super subjective. So like all the attributes are difficult in their own ways, but some of them are way, way harder to get the training data for than others. Some you basically need a fashion expert or a fashion consultant for.
It's funny that you say that sleeve length and like pant length and all that sort of stuff is like low hanging fruit. I used to hear customers complain about that all the time. Like, I want to know how long it is. And it sounds like for you, that was like one of the more simple things to do. So that's pretty cool.
Yeah, it was. One of the things that can be difficult with fashion images is sometimes they get cut off. So like there was this one issue we had where we're trying to predict skirt length for like a dress or a skirt itself. And there would be some pictures of dresses, like long dresses where it gets cropped. And then the model would say it was a mini skirt. Like all of these cropped images were put in the mini bucket. So I was wrong. But that's, again, one of the reasons why the text is so useful. And this is actually the subject of my most recent talk at ODSC East, is like how powerful it is to combine the image and text data together, because then a text will usually say it's a longer dress. And then you can combine them together.
But so that's different to a GAN, right? Because they like actually are intended to feed off each other. Or
okay, you just dropped the GAN acronym, so I believe we're going to have to call we need an explanation there.
Generative adversarial network. Yeah, almost got there.
Mm-hmm. Yeah, so those are different. So what I'm talking about is two separate models that take in different data and predict a thing, and then they kind of vote together. So you have your image model figure something out, your text model tries to figure it out from the text, and then they kind of convene together to figure out what's the best thing to do. Like a guy on my team calls this ensemble model Megazord. And I don't really get the reference, but it's like these two models are more powerful when they combine forces. And that's actually the reasoning behind a lot of what we call ensemble models in machine learning. So like a random forest is powerful because you have all these individual decision trees that each have different subsets of the information, but then together they vote on the answer. And we're kind of doing the same thing, only the subsets of the information is just the image on one side and the text on the other. So they're not adversarial at all. They are perfectly cooperating. But if you want to talk about adversarial networks, we can.
I'm just curious to hear, because like someone mentioned it to me the other day. I'm like, oh, wow, that's really cool. So I think it'd be awesome if you explained just like broadly the concept.
Sure. Yeah. So the concept here is that you have two different networks, so two different machine learning models. You have what's called the generative model, and then you have a discriminative one. So anyway, one of them tries to, like, you have a set of training data. So you have a set of known examples of a thing. So a thing we've done on my team is images of dresses. So let's say we have a whole bunch of images of different dresses. So what the generative model does, it looks at all those images and it tries to create a fake dress, what it thinks might fool the other model. And then the other model tries to figure out if that dress is fake or real. And so in this way, the generative model is trying to fool the other model by creating more and more realistic examples. And so as you train it, there's a loss function that determines that. But the idea here is to take the universe of dress images and map them onto like a latent vector space. And then once you have that mapping, what you can do is create fake dresses. So you can just pick points in that vector space and create fake dress images from nothing. You might have seen this in the news. People have done this with faces. So I saw an article, it's like this face does not exist, or like this person does not exist.
Yeah, it's a great website.
It's super creepy.
It also exists for cats too.
There's one for cats?
Yeah, the cats one is not as far along, honestly, and it's scary, honestly. Yeah.
When are we going to put more resources into cat computer vision?
Yeah.
Like, this is my dream.
But I mean, from fashion though, like there is a really good application where you could potentially show dresses that you haven't designed or productionized yet, see whether or not people like them, and then you actually create the dress, so to speak.
Yeah, so there's definitely like product use case there. So actually, my team has a blog post coming out soon. Like one of my senior data scientists wrote one called "This Dress Does Not Exist," and it's about this exact thing. So what he based it on was StyleGAN, which is a generative adversarial network that was built by NVIDIA in 2018. But he basically just repurposed it for clothing, and in particular for dresses. So he made all these fake dresses. But you're right, like that's the thing that we've been thinking about is like, how do we harness this for an e-commerce use case? And yeah, we could have people basically like design a custom dress, like their dream dress, and then maybe try to see what's visually similar to it that already exists in our catalog.
Oh, wow. That would be so cool.
Yeah. So like if you had some sort of dials or something that you could tune and say like, oh, I want to change this a little bit or make it a little longer or have a whatever sleeve type.
Yeah. From whatever list of 17 you want. Yeah.
30
30. Oh,
types.
wow.
Okay. Yeah, so many sleeve types.
30 sleeve types.
But then you can like help them find, their dream dress. Another thing that we're thinking of using it for is when we build these training data sets for these models, we have some categories that are pretty rare, so we don't have a lot of examples of them. So if you look at the full ShopRunner catalog of millions of products, we have a lot of dresses. So it's not hard to get a lot of labeled examples of dresses, but we have some really rare categories. Like the canonical example we always give is beach bags. So I guess that's a kind of bag, and we have 3 in our catalog. So even if we labeled all 3, that's still not really enough labeled data to make a model. So we want to use what machine learning people call data augmentation techniques, where we try to create more examples somehow, and they can be fake examples. But so this kind of like creating fake products can be really useful for filling out our training data set for rare categories.
Interesting.
Oh, that's so cool.
Yeah. So look out for that blog post in the next couple of weeks.
Nice. All right, we need to take a quick timeout because we want to hear from one of our sponsors here on the Multi-Touch Moment. Hey, Josh, you know how it is out there now. I mean, you spend 2 years slaving away over placing some Facebook ads, and suddenly you're a director of digital marketing. And, you've got to be able to communicate results to the business. You know what I mean, right?
Oh, definitely.
Yeah, and as millennials out there, and Mo's a zennial, we need to be able to speak the language of the people we're talking to. And I think this is where this product is really coming in handy. You've probably seen it because we're getting a lot of major attention right now, especially with social influencers. It's called Image-ine. You know that one?
Yeah, it's the millennial analyst's best friend.
It certainly is. And there's so many to choose from. So you really get a chance to communicate what's happening with all of your social media buying and selling of advertising in pictures and words that people of today understand and get.
Yeah, like when your follower count goes down, you get a big fat poomoji.
Yeah, so it's perfect. It's like the poop emoji shows you like, oh, the whole thing is down. Or, the big $ eyes emoji is like, hey, we are crushing it out there and we're getting tons of mentions on Twitter. Like, that's what people need to understand, and it makes it so simple. Honestly, I don't know how we got along before this tool came along to really help people understand what's happening out there with their advertising dollars that aren't communicating the results in emoji.
Yeah, it's pretty much the best thing since avocado on sliced toasted bread. And man, once you've used Emojilytics, it's really hard to go back to the native platforms. It all just kind of feels like a barfing face emoji.
Well, you know what they say. There's lies, there's damn lies, and there's statistics. But you know what? When you want the truth, you go to Emojilytics.
So you kind of mentioned architecture a couple of times.
Oh, yeah.
And where we've talked about having people annotate data, if you go out, Google, Microsoft, IBM, Amazon, they're all doing image recognition. So how much of kind of a balancing act, like what do you decide to or have to do in-house writing code versus leveraging third-party developed sources?
Yeah, so there are few options here. You're right, there are like AWS and Google and Microsoft all have fully out-of-the-box computer vision options that can do a variety of things. So those are good if you have really like standard things that they provide. So like you have to have use cases that match up to what they've built. So for example, if you're doing image classification, it has to match up to the preset categories that they already do. There's also a lot of face detection out of the box, and then OCR, so character recognition. So if you take a picture of text, it can transform it into actual text. So if you're doing some of these more standard computer vision type things, an out-of-the-box solution really can work pretty well. Yeah, those are the main use cases, I think. But then if you need something like, let's say you have different categories than what you find in an out-of-the-box thing. So let's say you have a very specific use case, like you're trying to predict sleeve types. I guess it's not something that you find in like the Google Cloud, like they're predefined categories. So there are also some solutions where you can input your own training data and you can get results without writing code. So there's Google ML Vision, Google Auto ML Vision, Clarify, and then IBM Watson Visual Recognition are all good examples of that. But when it came right down to it, like we really wanted more control over our model and our accuracy and the data set. And we had all these cool ideas for things we wanted to do that require not just the classification label, but the actual, like we wanted the embedding vectors from like the guts of the model. And that's not something that you'll get with most of these systems. So we really built everything in-house. We ended up using PyTorch for most of it, and we built our own APIs using Flask. But yeah, we actually went through it and built stuff ourselves. But I should say that it's a lot easier to build stuff yourself than it used to be because of a technique called transfer learning. And I'm not sure if any of you have heard of that before, but
is that the thing where like in the languages they were saying we somehow managed to have something that does Japanese and Korean and somehow it blends together and now can translate. I'm totally butchering it, but that's like my only reference was there was a language thing where it was learning to somehow, is that possibly in the same ballpark?
Yeah. So like all these models, like deep learning models, it's a network of a bunch of layers. And the lowest layers are learning like very basic things about images or language or whatever the problem space is. So just talking about images, like the basic layers of one of these models is just picking out like edges and shading, and there's a round thing in that corner and stuff like that. And so what we've realized you can do is, and not just us as ShopRunners, this is like something that people have known for a while and we're just taking advantage of, but there are all these academics that have spent a lot of time painstakingly building really, really fancy deep neural networks to do image recognition. And they've done them on open data sets like, for example, like most popular one is Image-ine, which has millions of images in thousands of categories. And it's stuff like cat, dog, boat, tree.
Image-ine, are those all ones that were somebody manually tagged along the way?
Mm-hmm.
Image-ine confuses me a little bit. Is that millions of images that have been manually annotated?
Mm-hmm. I think so, yeah. And so they have like 20,000 categories, actually. So what academics have done is they built all these different architectures, basically competing on this data set to try to see who can categorize it better. And through that process, people have come up with some really, really nice architectures for these models. So just like how you're arranging the layers and what the parameters are, like people have come up with some really, really great models. But these models are built to categorize ImageNet, so cat versus dog versus boat versus tree. But what people have realized you can do is take that model seriously. This is all you do. Just like chop off the last couple layers, put a couple new ones on, and then specialize it to your use case. And the way this works is because the lower layers, we're just learning general image stuff, like where you have circles and lines and basic properties of images. And that stuff is very generalizable to other use cases. So all you really need to do is just take like that end part that says, when you have circle here and a line here and a shading here, it's a dog. Just take that last piece off, put a new piece on, put some new training data through it. And it's way easier to train than trying to come up with something all by yourself. And so this is why a lot of people have been able to get really state-of-the-art results with these computer vision tasks without actually having to build the models from scratch. You're taking things that are already trained on this really comprehensive data set, and you're just kind of tweaking it to your use case. And so that's this technique called transfer learning. And we're using that heavily at ShopRunner. And we use it not just for images, but also for natural language processing. Now, that's actually a pretty new advance in NLP, is being able to do transfer learning there too. So the kind of models we use for images, we use a lot of ResNet models, VGG models, and then for images, we use UlmNet and BERT.
So all you need to do is get a PhD, learn VGG, ResNet. Let's not overly trivialize this.
I was literally about to go here. I'm like, you make it sound really easy.
Don't worry, everyone. We'll have it all in the show notes, so you'll be up and running in no time.
Yeah, I looked at previous episodes and I saw you put links in there, but yeah, and there are tutorials you can find on the internet where you can get up and running with this stuff like decently fast. So yeah.
I think the thing is, which we're not fully giving like enough accolades for, is like you make it sound easy, but I think that's because you're really good at explaining it, not because it's like remotely easy. Like I can't even get my head around between like an image being flat lay or 3D and like the amount of complexity that would even just alone add to the problem, let alone.
We don't do 3D stuff. I mean, maybe someday we could do 3D stuff. Like,
well, no, you do pictures of 3D models.
For apparel, it would be like on figure versus lay flat, like that kind of a thing.
Yeah.
It's not like actual 3D mapping.
Well, anything that's 2D could be made 1D just by taking all the numbers and putting them in one line. And that's seriously what these models do, is you have this two-dimensional grid of numbers. You can seriously just take all those numbers and put them in one long vector. And that's what you pass through the model.
But so, because I feel like something like 80% of the time when machine learning gets talked about, it is in the context of machine vision or computer vision, like the cats, dogs, hot dogs, that gets used as the example. And then even it was interesting when Mo said like, other examples, not to try to drag this back to like ShopRunner has this really cool, rich, where like the sky's the limit. There's like a million different ways you can pursue it. I can say at Search Discovery, we've had one example where we did machine vision type stuff that I don't understand how we did it, but we did it around like trying to predict social media performance for images. But it seems like
how did you do that?
As in whether the post would be popular?
Well, it was like taking a huge volume of digital assets and then taking the ones that had actually been used on social media and then trying to figure out what features could be derived from those images that they can be modeled and predictively say, oh, these images appear that they will do better. I'm not even sure how we define better. Not a client I worked on.
But Tim's using it personally just to become a big time social media influencer.
Yep. I'm gonna get that 14th Twitter follower any day now.
Hashtag live your best life. Hashtag blessed. Hashtag yoga in paradise.
But I feel like there's so much talk of machine learning, and then we get the image side of things and trying to, like, I certainly know of brands that have a massive library of images that they don't. They have 7 tags. So that seems like one that is in kind of a digital asset management world that, hey, figure out what else you want to sort of featureize out of these images, do some training, and then cut that loose. And now you can probably make a richer experience on your site because you have more kind of structured data around your images.
Yeah, definitely. Where we humans don't just see a vector of numbers, right? Like we see these categories that people care about. And that's the whole point, is to create these filters that make it manageable to go through the catalog. People are not going to flip through 2 million images to try to find the product they want. They want things in neat categories that they can search through. So that's what we're trying to do.
But it's interesting. It seems like that's if you're an analyst, a traditional, humble analyst, and you're in an environment where you say, we know we have a sea of images, whether they're our images, whether they're ours and our partners' images. Mm-hmm. If no one's thinking about it, then it makes sense to dig in a little bit and try to think about where's the potential. And then go get a PhD or hire a couple of PhDs, learn ResNet, BGG, other acronyms, deep learning. And then it's very easy.
PyTorch, Flash, all those things.
You definitely don't need a PhD to do this stuff. And I have people on my team that don't have PhDs.
It's always just, okay.
Yeah.
No. Okay. We're at a very good point of which we could kind of wrap up. Ali, this has been tremendously informative. So thank you so much.
Yeah, no problem.
Actually, we do a thing called the last call where we go around the horn and we share things that we're interested in and we found interesting that we think our listeners might enjoy. Ali, you're our guest. Do you have a last call you want to share?
I do, yeah. So on the subject of learning about this stuff, I would highly recommend the Fast AI course that they have. It's called, I think they probably have multiple courses, but there's one in particular that me and my team have loved, and it's called Practical Deep Learning for Coders. And version 3 just came out. I have multiple people on my team who've actually learned deep learning from this class from scratch and are now doing this kind of work as their job. So, and
the coders means they're well versed in Python. What is the for coders?
Yep, it's Python based. So I love that class. It's taught my team a lot. We've grown a lot of talent in-house using that class.
Nice.
Tim, what's your last call?
So one, as we were talking, I did realize that the playing with the easy stuff, that I had to go look at it, but it was actually over 2 years ago. I spent a period playing around with the Google's Vision API with the Rugal Vision. So a last call from episode number 71 was me having fiddled around with pictures I had taken and throwing them up into the Google Vision API, which was actually, it was, to Ali's point, that being moderately okay with R, I was able to actually do some interesting stuff with images that were personal images, identifying various buildings and landmarks. And that was kind of interesting.
Cool.
And then my second one is going to be a weird kind of throwback to the last episode because it hadn't come out when we chatted with him. Pixelate did their Q2 ad fraud survey or study. So when we had Augustin Fu on, and he talked about kind of his estimates of the scale of ad fraud, the Pixelate came out with a study, and kind of one of the stats that bubbled up was that their estimate is that 19% of programmatic traffic in the US is actually fraudulent, which is lower than what Dr. Fu would have estimated. It was actually the place I picked it up from. Also thought it was a fairly optimistic view, but it's kind of a good read because there's a lot of slicing by country and by other characteristics. You have to put in your email address to get the PDF, but ad fraud, it's a real thing, people. So that's my twofer.
All right. Perfect. All right, Mo, what about you?
I've been hanging out with Tim too much because I've got a twofer as well. So we had someone present a couple months ago. Her name's Claire Carroll. She's a DBT community manager at Fishtown Analytics in Pennsylvania, but she's actually an Aussie, and she came out and presented to us. Anyway, she talked about a post by Michael Kaminsky from the Locally Optimistic. And we keep going through where like I occasionally have a meltdown. I'm like, maybe analytics people should just call themselves a data scientist and they get more money. Well, he has a new term of phrase that he thinks analytics people should be calling themselves, and that's analytics engineer. And it's basically the fact that like, and to be fair, my team are like this. My team does probably more data engineering than analytics work. And I don't have a view on it yet. I'm still just like, oh, that's weird. So maybe that's going to be the next new sexiest job of the year.
We're all in search of that one job title. It's going to finally make us complete.
Yeah. Going to make you happy.
They're the analytics translator is going to talk to the analytics engineer, who's going to talk to the business analyst, who's going to it's going to be like a whole army of people trying to talk to one data scientist.
Yeah.
Well, I've actually, it's been suggested to me that my team be called machine learning engineering and not data science. So
there's people at my company called machine learning engineers. So
yeah.
Yeah. But the other one actually I found via Adam Singer, and it's not actually work related, but I think that everyone in the world should read this article because it really resonated with me. And it's called Why the Millennials Became the Burnout Generation. And it's a long read, but I don't know, something like really clicked about like what's kind of going on with our generation and like, I don't know, approaches to work. And
wait, whoa! Did you just say art? Because you said you're a zennial. You're not a millennial, Mo. But all of a sudden, apparently, when it serves your purposes, you will claim the millennial.
I am technically a zennial.
But Mo, you've gone to great lengths.
Well, I don't think zennial's like an actual definitional thing. I think people that are zennials made it up.
I believe we have audio evidence where you tried to claim that it was for the 17 minutes that you were born.
Oh, anyway.
So anyway, but as we are all here millennials, keep going now.
I'm borderline the greatest generation.
Anyway, I think it also really resonated for me because as a zennial, I sometimes am working with millennials and it made me have, a different perspective, particularly it's very focused on the American market. But I think it is an incredible read, and I would recommend anyone that works with or knows a millennial, aka the whole world, to read this article. So, all right, I'm done. Off the soapbox.
Nice. I like it. And Adam's always a good read. So that's awesome.
There you go. All right. So I have more of a 1.5. So we were talking about machine vision, and it totally reminded me of sort of a funny thing I saw a little while back. It's actually been out for a while, but there's this guy named Matt Parker who does comedy routines about spreadsheets. And in one of them, he does this whole thing about how he loads an image into an Excel file, basically recreating all the pixels of the image. It's hilarious. Has nothing to do with computer vision necessarily, but it's pretty funny. And
so you can actually build neural networks in Excel. Just putting that out there.
Again, I think your use of the word "you" might be a little.
All of us here as millennials, Tim, I think we really need to not limit ourselves.
One might.
That's a topic for another show. Wow, a neural network in Excel. That's really got me thinking.
Yeah.
All right. So my actual last call, that is a funny video. Watch it if you have time. But my last call is also, this is why I thought you were about to steal mine, Tim, because after our last episode, Uber's lawsuit against their mobile vendor Funware got posted online, and it's a fascinating read about how ad fraud happens in the real world. And so the company was doing a lot of very interesting shenanigans to bilk Uber out of money, which back at that time, I think all of us would be okay with that happening, just given the leadership of the company and so on and so forth. But, it's probably happening to really great companies. And so it's really interesting to see what's happening out there. Very interesting read if you're interested in the ad space at all and how it intersects with people who are out there fleecing companies. That's a very good lawsuit to read. Okay. You've probably been listening and you've been thinking to yourself, my gosh, why won't they finish these last calls? But before that, you were probably thinking, wow, this is super interesting and how can I learn more? And there's a lot of really cool stuff. So if people wanted to find you online or see you speak, Ali, where could they go?
Yeah, so, people can check out the ShopRunner engineering blog. That's pretty new, but there's some content up there now, including a talk that I gave at PyData about using Flask to build web apps for data scientists. But also you can see me if you happen to be in Seattle on October 17th. I'm speaking at the Data Science Salon out there.
Excellent. Thank you very much. And if you want to get in touch with us, you know how it is through the Measure Slack, because that's where we always hang out all the time, or on our Twitter account or on our LinkedIn group. And feel free to come aboard there. All right. Thank you, Ali. This has been super informative. I think as a topic, it's been really cool to get a deeper understanding of it, or at least, a glimpse into an understanding of it, which is not your fault. That you did
on the neural. We're at the top layer. There are multiple layers of understanding.
Yeah.
We're in the first branch.
That I'm in that base layer of line, circle, line.
Nice.
Yeah. So I'm going to do some transfer learning later and I'm going to get up to speed here. But no, thank you again so much. Really appreciate you coming on the show.
Yeah. Thanks for having me.
And for all of us here, we've got a great producer in Josh Crowhurst, helps us put the whole show together. So big shout outs to Josh. And for my two co-hosts, Tim Wilson and Mo Kiss. No matter what images your computer is trying to envision, your job is to keep analyzing.
Thanks for listening, and don't forget to join the conversation on Facebook, Twitter, or Measure Slack group. We welcome your comments and questions. Visit us on the web at analyticshour.io, facebook.com/analyticshour, or at analyticshour on Twitter.
So smart guys wanted to fit in, so they made up a term called analytics. Analytics don't work.
Analytics. Oh my God. What the fuck does that even mean?
Oh my gosh. Did I explain that okay?
It's okay. Even if people don't get it, they'll never admit it because they don't want to look like they don't know what's going on. Why do you think I didn't interrupt you 40 times on this recording? Be like, wait, you just said a word I don't know.
I so was ready to make a vector joke, and you just kind of teed it right up. You see the Mona Lisa. I see a string of zeros and ones in a binary vector.
How is that a joke, Tim?
Well, it amuses me.
Okay.
That's how Skynet goes to the Louvre.
Are you serious right now? I think you're about to take mine.
Dun, dun, dun.
Dun, dun, dun. I have important show business. Mo.
And Tim was going to yell at me anyway because I was starting to talk about show content before the show.
That's okay. That's part of our whole thing.
Save it.
No, we have to do it that way. Mo has to get one or two really awesome questions in before we ever start recording. It's part of our process.
And then Tim wants to kill me. Yeah.
I committed to doing one a day from a songwriting. Songwriters come up with hundreds of songs they never record.
Oh my gosh. You and Lady Gaga, Tim.
That's right.
He's the Lady Gaga of fake analytics ads.
That's right.
Hold on. Let me go put on my podcast steak.
I'm in the deep end.
Because I feel like for lots of people, I'm not going to lie, I didn't know it was called computer vision. I just thought it was image stuff. And then Tim started eye roll at me.
Rock flag and sleeve types.